That's something to note. So now we have this. Let's jump to the materials, and connected to that, we'll also jump into looking at our scene a bit differently. For that, we first want to make sure that in the render properties we have selected Eevee, which is like an advanced real-time viewport, and let's click on this here, the viewport shading. Let's give it a moment to load. Pink means when it's like this purplish pink, it means it cannot find the texture. For that, we quickly want to locate that texture. Don't worry about it. We'll do that in a second. So now this character has a texture applied. It's a bit dark. So right now, this is the standard that comes with Blender. There is a light here. So it looks a bit not so nice, but you can see you can move the light around by selecting it, and then you can see how the light interactively reacts to everything. Now there are a few things that you want to enable in Eevee to make it look better. One is the ambient occlusion here. You just put a check mark. You probably want to also add a bit of bloom. That looks always nice. You can see the difference. Then screen space reflections you want to turn on. For shadows, use high bit depth shadows. Volumetrics we're not using right now, but we'll be doing it in a second. Turn on volumetric shadows. And that is everything we need right now. You can also, for the ambient occlusion, change the distance to make sure it fits your scene. You will see how it changes depending on how large your scene is. So that's okay, but it's not very pretty. So let's actually go into the world settings. And here we have the background. We can change the background color, which is great. There's unfortunately no simple sun and the sun system built right into Blender. You can get it with plugins, but the easiest way to get something here that looks nicer is, for example, an HDRI, a complete, like a 360 photograph with lots of dynamic range that can help us light the scene. So in order to load that in, you're on the world setting here, hit Shift A and you get this. And then you can select out of a variety of things. You can either go to a texture and then set environment texture, or you can just click search and hit and find environment texture. And now you have a new piece here. The nodal interface is something that a lot of other programs have. Basically, you have to just for now treat it as like this kind of stack, like a layer stack in Photoshop, but just turned on its side, which means this one here is on top. This is the output. This is what will be shown here, and the information travels from left to right. So here the background feeds information into the surface of the world, which sounds a bit weird, but it's basically what you see here. And the color will influence what we see, right? So if we have it purple, then the surface is going to be purple. The strength is basically like how bright it is. You can have it very bright or only a little bit. And then now if we want to plug in a HDRI, you press and hold and you get this handle. You plug that into the color. A lot of stuff here you just need to learn. Don't worry about why it's called this way and that way. Basically, this is like a piece, a node that will allow us to import an HDRI. So you need to, of course, download some. There's plenty of cool ones around. Let's choose something I have here. I don't know. This should be fine. You can go to places like hdrihaven.com and you can get them. So now we have this photograph that is mapped here, and you can basically move around, and this will inform our scene and will inform the light and everything that is cast and the colors that is being used to light this. I want to get rid of this light actually. Now it's a bit dark, but basically what we want to do to get better lighting is we hit Shift A, we add a new light and we call it the sunlight. And it's here. So it doesn't really matter where it is because it's like a unidirectional light that will be, that just lights up everything regardless of where this light is, compared to other lights which, for example, you want to add a point light. It's basically light that radiates from one point outward. With it selected, you can go here and increase the power just to have it show up. You can make it really big. So now it's really strong. You can see how it influences the shadows and everything. The point light also, there's another one, which is the spotlight, which, I mean, it's pretty self-explanatory what a spotlight is. So you have this cone, which shows the direction of the light. And compared to the point light, this, of course, only casts light into one direction. So you can move it around. You see how it casts a shadow here, you see. And there's another light which is called an area light, which is more like a soft, light that you can have from, that kind of shines the light in the direction of this large thing here. So you can rotate it. It's not as harsh as a spotlight, and it's very good to light environments, interiors, and that kind of stuff. But for now, I want to use the sunlight because I want to mimic the sun that comes from here. Because you see, it doesn't really, without this, it doesn't really give us the right kind of shadows I want. So we need to emphasize that. So the sun is kind of coming from here and here, and is like, the color you can change here as well in the settings. More like a bit orangey. So now this light fits a bit more the light that we have here. It's also very strong. You can bump it up a little bit. You can play around with it to get it exactly comfortably matching the light that comes here. So now we have this, and sorry that I'm jumping around a little bit here, but you kind of need to develop these kind of things go hand in hand, like the lights together with the sun settings, together with the HDRI. That's kind of I think easier to explain, to see how these things change and influence each other when we see it in a scene. Again, that's where it comes from, that I'm more from a design background, from like a technical background. So you can see how the bloom and the EV render kind of like gives us this like blooming from the sky here, which is quite nice. This one I want to get rid of. It kind of works together. It makes it look better. So now we have this. We can look through our camera. Yeah, that's our camera. We can frame our subject. Maybe get rid of this one. And you can see I can manipulate the scene, and I can look through my camera to see if what I'm doing makes sense. And now we can actually do some texturing maybe on this. I don't know what it is. Let's make a plane. Maybe let's, I don't know what this is. Let's get rid of it. I bring this here. I scale it up with S. And now she's in the water. Let's move it down so that she's firmly on the ground. And we want to just have some kind of floor. I don't know what kind of floor, but let's see. Just an exercise in texturing. Let's change to the object settings. Now make sure you have this selected. And then you can press New here. Okay. You can also click in here, and you can say it's the ground And now we have this one here. It's called the principled BSDF. Forget about the name. It's just the main shader you want to always use for most of your stuff. So you click on the color here. You can change it. Looks fantastic. In the same way that you can, if you don't like the color you just selected and you want to go back to the other one without pressing Control Z, you can just hit escape and it snaps back. So it's like, oh my gosh, it's too pink. Like hit escape and it's gone. We might want to plug an image in here. So for now, let's leave that. There's a lot of stuff here. Most of it I don't use. What's important is, for example, the specularity and the roughness. So let's look at the roughness. If you decrease the roughness, it means the surface is less rough and more reflective. So you can see how once we get close to 0, it becomes like a mirror surface. If we go up, it becomes completely non-reflective, like a super rough surface, like a rock or something. You can play with that. The metallic one does exactly what is specified. It makes a surface very metallic. It works together with the roughness. So you can see how that becomes even more reflective. If the roughness is not all the way down, the metallic one will not work properly. At least not how we want it, with a very reflective metallic surface. So we can use that. And the other ones, don't worry about it. This one is actually, you can make stuff transparent, but don't worry. The emission, yeah, you can use that, but it's also nice to use the emission shader itself. Don't worry about that for now. Again, I just want to show you the basic stuff here. So now actually I want to use an image texture. So how do I do that? You can press again Shift A and you can say texture, image texture, or you can just search image, you plug it here, and then we basically connect the color to the base color here. And now something happened, but it can't find anything because we don't have any texture plugged in. So let's change that. Let's find something interesting. Let me see where my textures are. So you can change this one here into a thumbnail list. That makes it a bit easier to see. This is just some random stuff. Some of these are non-tiling, which is annoying, but I use them for all sorts of stuff. Let's see if we have like a tiling texture. Or if I have a tiling texture somewhere else. With this stuff, it's good to have a variety of cool textures and stuff you buy. The benefit of 3D is having all of these things and have them and buy them, of course. That's the bump, that's the floor. And buy them and reuse them and modify them and all sorts of stuff. That is the benefit of 3D and how you get really fast by having a lot of assets and a lot of pieces you built yourself or you bought. So now we have this, and it looks like, doesn't look like concrete or anything. It's huge, it's weird. So one thing is that once you plug the texture in like this, it will use the UV layout that comes with these, with these pieces of geometry. Just a way that the texture is mapped onto this object. Now, if you're like a 3D artist, that's fine. But once you have like more complex geometry, like let's take this as an example of complex geometry, even though it's not. But this kind of stuff will work fine on a plane or something, on a standard object. But we can click here, we can click ground. But once you see, like, once you modify this object, it looks terrible and it rips apart. So what we need to do is, or what I recommend people to do, is that we want to have this material applied regardless of this UV map, how it's called. and just have like a standard way of applying it everywhere without having these weird streaks and where the texture is breaking. So we need to give it a set of information to actually do that. In order to do it, you need to learn this, and this is just some things that they are the way they are. So you want to go to, again, input texture coordinate. Here you have a variety of ways that we can instruct the texture to be mapped onto this. We also need a you need to go to vector and go to the mapping. And we need a third one, which is called the vector transform node. And you put that here. So you line them up like this. Basically, we want to say, like, take the object coordinates and use that and convert the object coordinates into world coordinates. That means that it will disregard whatever the object coordinates, the object way of linking the texture to the object is, and disregard it and make it into use the world measurements so that we can guarantee that the texture is going to be mapped in the same scale to all objects, regardless of how big they are. Then we move the vector to the vector here, vector to vector. By the way, if you hold Control and you right click, you get this knife and you can cut this connection. Very useful. And this vector goes to this vector, so the information flows like this. So now it looks weird again, but we need to do an additional step here, or two actually. We need to change flat to box, because this kind of mapping is often called box mapping or triplanar mapping. And it still looks weird. What happened, right? So there are still scale, there's still information in this piece of geometry that we need to get rid of, because I did this and then I scaled it up and then it ruined everything. So basically I have to reset the scale and the rotation and everything else for it to get proper normal coordinates again. Very technical, but you do it once and you know how it works. So once you've done all of this, you press Control A and you say apply rotation and scale. And still doesn't look pretty. Let's do it here again. You can also select multiple objects and press Control A and it will do it for everything. But now we actually have to go into the mapping, and I usually change it to texture. And now you have these scale. Oh, let me zoom in. You have these scale pieces here. And okay, you need to do a bit of acrobatics here. You click and hold and you drag down until all three are selected. And then once you move the mouse left and right, you can scale these up. Now, textures, you need to always keep in mind scale. So if you work on any kind of like design idea, concept, whatever, you have to have a human scale model next to it, if it's supposed to be for humans. And then you need to see, okay, how big should this tile be for it to make sense? Because this makes no sense. And this makes also no sense. So you need to find that sweet spot based on real world reference to see exactly how big should these tiles be for it to make sense. So now that looks okay. You see that the texture is applied in the same scale as the ground on this object, which is good. So now we need to work a little tiny bit on this shader. Now, if you have purchased something and it comes with several passes, then that's great. So you can plug in like a roughness map into the roughness, into the specular. But let's say you have just like a image you found somewhere, or it doesn't come with all of that. You can still kind of get around it by, for example, plugging the same map into the roughness. And it's not as ideal, to be honest, but it still will give you some benefit of the texture. So we need to make some modifications to that though. The good thing is that we do not actually need to touch this image. Like you don't need to go into Photoshop and then change the JPEG and plug another JPEG in. That's very costly, very expensive in terms of performance. So what you can do is we can actually, within this flow of information, we can add modifications to it. So let's say we want to invert it, like, because the thing is that roughness will only consider the black and white values of this image. It will throw all the color information away and just use it from black to white, the values. So if you do this, it's fully 100% inverted. So whatever was white in this image is now black, and whatever was black is now white. Now we can change how much the inversion is supposed to be, and you can see how the surface changes from fairly dry to quite wet. So now we have like a dry kind of surface. Of course, you can take a completely different image, right? A completely different image. For example, let's copy this over. You copy this by pressing Shift D, which is also the way that you copy objects. So click on an object, press Shift D, and it's moving around. So now you have two. Creepy, let's get rid of it. So now that we have this, we can give it the same kind of coordinates, which I don't need to duplicate this. I only need to duplicate this if I want to use a different scale. So we can plug this into our roughness channel here, and then if we click on this one again, we can choose a different texture. And for example, like contrasty black and white images work well for this, for these kind of roughness. So now we have like a really dirty ground, but let's like scale it differently. And in order to scale it differently, we need to give it a different set of instructions because this one tells the concrete how big it is. This will tell the dirt how big it is. So you can see how we can, it doesn't tile well, but it's going to be okay for this demonstration. Now we have this inversion node here. We can, if you see, you hover over it, the connection line here highlights, and now it's inverted again. And now we can play with it. It doesn't look like the most realistic thing, but at least it gets the point across here. So it looks like a wet floor, a dirty floor. And here it just looks like, I don't know what. You can also use this again multiple times. Looks a bit different again. You have to influence the specularity of this. You can play around. One thing is that you should never be too stuck by this kind of format. You should experiment, use textures that you would not think would have actually made a lot of sense. So now we just have a bit of dirtiness here. Look at dirty tiles, right? Kind of. So don't be limited to the very strict format or only stick to things you purchased. You can always do interesting things by yourself and experiment and play around with the shader network. This will get some time to get used to, especially if you've never tried a nodal interface before. But no worries, you'll get used to it. So a couple of quick things that I want to show in the end, and that will be useful. And that will conclude this little overview is, for example, fog. So fog can be very quickly done either through this volume thing in the world output, or we can actually build ourselves really quickly a fog volume. So we do that by, let's make a new cube, and we make it, we just have it encompass the entire scene. So it's like nothing sticks out. It's great. let's give it a new material. We call it fog. We get rid of this. Just select it, press X, it's gone. We get a new one called the principal volume. We plug that volume into the volume, not the surface, the volume of the material. And we get this. Looks fantastic. So now what we need to adjust is the density. We set it to 0.1. It's probably still very dense. And we have fog. There's many different ways of how you can get more interesting fog with all sorts of modifiers and shaders and blah, blah, blah. But for now, a simple fog is this. And you can also, for example, have another light. Let's just add like a point light to just get the point across. No pun intended. You can see how when we play with this light, it actually reacts to the fog, or the fog reacts to the light, so to speak. You can see we can make the fog a bit thicker. Now it's very dusty. And you can play with the color, and that's it. So let's say you're like incredibly happy with what you have produced here, and it's like the best thing ever. How do you actually get it out of Blender? So first we should jump into our camera view. So now you move the camera exactly where you want it to have it, and you want to render it out. And it's really very easy, because let's say everything is cool, and then you just hit F12. And there you have it. And it looks absolutely beautiful. So a new thing pops up. It uses the resolution you have defined here. So don't forget that. And now we can actually say view in our image, save as, and then you can save it as a PNG file. And it's beautiful. There's also a couple of other passes which you might need and want for assembly in Photoshop. And it's very easy how to get those. In the latest version of Blender, I think 2.82 and 2.83, you can click on this little arrow and you can say render pass, and you can say, where is it? Mist. So we have this mist pass, and in the world settings, we can actually change the range of the mist. So right now it's good. You can use this to isolate objects, to add more fogging to your scene. If you go to the passes here, the layer properties, you can enable mist. And if you go to the world properties, you have an additional mist control here, and you can make it exactly how you want it, how it works best for you. And then you can say view, viewport render image, and you see you have these annoying things here, so you need to get rid of those first. And that's here, the overlays. You get rid of the overlays, you say view, viewport render image, and it's clean. You say image, save as, and it's done. And in the same way, you want kind of like a selection pass, where you can select your objects based on like a unique identifier for each object. So in order to do that, you go back to the viewport shading, you click on here, you say flat, random, get rid of the outline, and now every one of these objects has a different color, which makes it, once we go to view, viewport render image, which makes it very easy to just use the magic wand in Photoshop and select these. So you don't need to do that manually with like a selection tool or whatever. The colors are a bit faded, but with a little levels adjustment in Photoshop, you can fix that quickly. So, and then we go back to Studio, Material, enable the outline, enable the overlays, And we're back to our beautiful scene here. So I think that's pretty much all for this introduction. That should be, I think, something for you to play around with and just serve as a entry point to Blender. Of course, you can then move on to more exciting stuff. I have plenty of tutorials available on my website and the usual marketplaces. So please have a look at those, and you can follow me and ask me lots of questions on Blender and other stuff on social media. I'm everywhere. Thank you so much for watching this, and see you around.
Hello, everyone. Thank you for joining us. My name is Daksh Pandey, and I am the lead developer on Gaia, and I'm also one of the co-founders of QuadSpinner. So, again, thank you for joining us on this online event. In this session, we're going to talk about large-scale procedural terrains, and we'll show you some of the new tools that we have on how to quickly get an asset ready, whether it's for game or ArcViz or VFX. Originally, this was obviously IFCC was going to be an in-person event, but because of all the things going on in the world, it can't happen. But thankfully, we're all together online, and before, like, I was talking to the IFCC organizers, and they were talking about how they want to make this feel just like a real in-person event, even though we're all sitting in our homes or offices. So to make that happen, we're going to have a PowerPoint slide that's out of order. We're going to have a video that doesn't play, and a software that'll crash about 20 minutes into the demo. So hopefully that'll make you feel just like a real event. So anyways, once again, thanks for joining us. And okay, so what you're seeing here, this mountain, this rugged landscape, that's something we're going to create today. And even if you don't have any experience with procedural terrains or terrains in general or graph-based applications, that's all fine. We're gonna look at how easy it is to create this with absolutely no prior knowledge. So all the bits you see here down here, that's the graph. Those are basic functions. Like, each of those nodes represents a little thing that we do to our terrain. So it basically procedurally models the entire terrain for us. And so we start with a little mountain. And so just like, in whatever CG application you use, you have primitives like cubes and spheres. Well, because we're dealing with terrains, the primitives in this case are mountains and valleys and craters and so on. So we basically give it a different instruction on what we want it to do. Like, so first we create a mountain, which is generated procedurally. It looks a bit weird here, but don't worry, we'll go through that and you'll get to see how it all works. And then we erode it, which is like a natural process that turns any geometric shape into a realistic looking landscape like this. So this is what happens to a real terrain over millennia as it experiences rainfall and other natural processes. So anyways, we go through all of these things. We make the shape look even more rugged and cool and interesting. We do a few more things to it, like adding a bit of snow. We also let the software texture this for us, where we kind of get like a little bit of control where we want it to be. So you can, like, put in your creative direction. But then the software, because it's procedural, it'll take care of doing all the hard work for you. And the other great thing about this being procedural is that you can go back, it's non-destructive, so you can go back into, like, here, and then make some changes, and the rest of it is automatically applied. Now, if you've never done this before, I know that's a lot to take in. So we'll just start simple. I'm just going to create a new file. And in case you missed it, we're using a software called Gaia. So we built it here at QuadSpinner. It's made for creating procedural landscapes, and it has this is the main interface. It has hundreds of nodes for you to choose from. It has things for all kinds of different functions you might need for a terrain, and sometimes even more abstract stuff. So one of them, we always start with like something that creates something like a primitive. So, you know, if you're modeling something, you might want to start with a cube and then subdivide it and do things to it. So in our case, we have a mountain. So this is what the mountain primitive looks like. And it gives us just like a basic mountain shape. Now we can change the seed, which is just like the random like a random seed. So you change it, it just grows a new mountain for you every single time. So not too different from any kind of noises you might have used in shaders or material editors and so forth. So looking at this, you can see you can get like a wide variety of shapes. They kind of retain their general flavor, which is mountain in this case, but they also give you lots of different options. So I'm going to right click this slider and select reset, so we can go back to the original shape, which is kind of cool because it has that, you know, lone mountain peak, very like Lord of the Rings style. The preview looks a little low resolution, so I'm going to go up here and change the preview to 1K. Now, because this is procedural, it doesn't matter if you're going to output this in 1K or 8K. So this is just for our previewing. And so if you have really complex graphs, you might want to go down to 0.5, or if you have really simple graphs, you can go up to all the way to 4K and see that preview. Now I'm going to stick to 1K because that's more than enough for our needs, and it keeps the processing a bit faster. So we started with the simple mountain node, which is part of the default template whenever you create a new file. And then we have an erosion node. Now this is a very key thing when creating procedural terrains of any kind, because erosion is one of the most prominent forces in nature that creates the different terrain shapes that we see. So here you can see that because we started with this rugged mountain shape, while it looks cool, it does have that slightly CG feeling because you get a bit of noise. It's like, you know, nice and random, but at the same time it doesn't have the kind of soil structure that we associate with real terrains. So when we add erosion to it, it starts creating all those the soil structure that I was just talking about. So the erosion node, it's basically just a complex simulation that it simulates rainfall, which then takes the sediments away. It creates channels and so forth. It has a lot of different settings, but for our purposes, we really don't want it to become too much about erosion, just like to be like the big driving force behind our landscape. We're just going to make it like one part of a larger process. So the I'm going to increase the duration a little bit. I'm gonna, instead of 4%, I'm going to make it say 17%. When I apply the changes, and to apply that, you have to click apply changes here for some of the heavier nodes, because they can take longer to process. We don't automatically process it for you, so the software basically waits for you to hit that button. And so now with more erosion, you can see that instead of just simple flow structures, we're now getting really cool complex formations. Like this is what you would identify with larger mountains. The only thing is though, this kind of made it a little skinnier. So our original mountain has like a nice bulk to it, but because we're eroding, and eroding by definition takes things away, so we're kind of losing some of that. So that's a key thing for erosion. You always like bulk up before you erode, especially if you want to retain the shape that's already there. It's kind of like carving up before a run, which is, something I know about only in theory. So let's go back to our mountain node. And below all these properties that we get for our mountain or whatever node, at the bottom, you'll see there are a bunch of buttons. These are the part of the post-process stack. So these are common things that you would do to a node or a height field, which is basically what this is. It's just a displacement height field. And so instead of having to create extra nodes for it, you get like common functionality built into all the nodes. And so one of them is this one called Shaper. And so Shaper helps you bulk up or bulk down a node. So if I were to bulk it down, you can see it becomes this tiny pinnacle. But if I were to bulk it up, see, we lose the core shape in a way, but it bulks up so much that we can erode it that much more and get more beautiful soil structure out of it. Maybe 55% might be a bit much, so I'm just going to right click and type in 40% and hit enter. We can maybe go a little bit lower, so there, 28. This looks good. We get some of the core, and then even though it's not visible, it's still the same mountain. Like if I turn this off, you can see it's still there. We're just bulking it up, which is going to be good because we now have a lot of erosion to apply to this. So at 17%, you can see that this got eroded. We got all these cool flow structures and all these lines that created from the soil down cutting. And then at the same time, it still is quite large. So that gives us a really nice mountain to start with. Now, with the basic mountain done, we still needed to be more rugged. We wanted to have, more character, because just having smooth, eroded mountains is not really the way to go, because sometimes that can actually scream CG. So what we're going to do is we're going to create a second primitive. And to create that, I'm going to drag this. It's called Worstlands. And so I'm going to drag it from the toolbox and drop it here. And this is what it's created. So this is one of the several geoprimitives which give you the structure of a predefined landscape. And so Worstlands is basically, well, it's worse than Badlands. It's the kind of landscape where you wouldn't want to get lost. Let's put it that way. And what we're going to do is we're going to transform this a tiny bit and then use this as the floor for our scene and have the mountain be something that's coming out from that floor. And we'll kind of get some of the more rough qualities of this into our main mountain. So we'll come back to that in a moment about mixing and merging. So what I've done now is I've created a node chain that's separate, and that's fine. So this would be the same as creating a separate object in any other 3D application. We can then merge them together, which is kind of like a Boolean operation, but in this it's slightly different. Anyways, so with the Worstlands, I like this general structure that it has. So we can kind of try to see what other things we can get by modifying some seeds. Just manually enter this magic value of 4339, which was a seed I encountered earlier while I was practicing for this. I know we're not supposed to say we're practicing, but you guys mean so much. I wanted to make sure that we showed you something really cool. So I found this seed. Again, it was just random. I kept looking for something and then I saw this and I wrote down the number. And this has kind of like a peak structure in the center. So we kind of get to like piggyback that into our main terrain. And then so we already have a super rugged terrain structure here. Whether we see it from the sides or we see it from the top, it looks pretty cool. But, you know, I want to add a bit of cragginess to this. Now, because we're going to merge this with the other terrain, I'm not going to add too much just yet. we'll make that the next step so that we can give it to both these terrains. So if you're going to do any kind of processing, it's better to do it after you merge different pieces. And I'll show you exactly why right now. So what I want to do is I want to drag the output from the erosion node, drop it, and type in combine, and then hit enter, which creates the combine node. Now it needs a second input because it wants to combine two different things. And so I'm going to bring in Worstlands, and there, we're now blending these two equally. And so you can see it's kind of getting the best of both worlds right now. There are different ways to blend this. So instead of just common blending, which is like take 50% of this, 50 of the other, I'm going to go add, or in fact, I'm going to go screen. These are just blend modes like you would get in Photoshop, and they do things exactly the same way. So by making this use screen instead of blend, I can push the ratio to 100%, and we can just get all the roughness from the Worstlands node underneath into the mountain node above. So this somewhat less chaotic, smooth looking terrain, especially towards the side, suddenly becomes this. And you can of course control the ratio and just do whatever you want to do, to modify the node before that to merge. You could even mask this, which is a great way of doing certain things. I can show you exactly how that works. So I'm going to right click and type in height, which this is a shortcut. If you right click and type, you don't have to go looking for a node. You can just type it in and then hit enter to create that node. Now I'm going to connect this to the erosion. Now you can see whenever we work with masks or bitmaps or anything that is not like actual displacement, the viewport becomes flat. So Gaia needs to know at this point what to visualize as the height map underneath. And in our case, it's erosion. So I'm going to right click erosion and mark this as an underlay. So I'm going to pin this as underlay. Shortcut for it is G. Now when I go to the height, you can see that it's being visualized on top of that. I could go and do the same thing here. You can see the little purple dot here that shows us what is the current pinned underlay. It's moved to this, and I go here, and you can see it looks okay, but kind of doesn't make complete sense because they're kind of coming from different things. So I'll move it back to erosion so we can visualize this properly. And so the goal of the height node is to help us select a bit of height. So what I'm going to do is I'm going to turn on normalized mode, which gives us the full height range. And now I can move the min slider all the way down and the max slider a further bit down as well. Okay, there we go. I think that's good enough. The fall off basically helps us create a softer mask. Like this is what we have right now, but we don't want it to be a hard edge. We want it to be nice and smooth. So I'm going to add a bit of fall off. Now, every node, or almost every node, has a port, an input port called mask. So does combine. And so if we take height and plug that into the mask port of combine, you can see we are now masking everything with a mask that was applied here. So now the effect of the additive effect of screen only applies to the sides. So if I were now to go back to blend, you can see these two are emerging very differently. One of the reasons is because Worstlands is quite higher. So if I go down here to the side, you can see it's much higher than the mountain. So what I can do is I can go back to Worstlands, go back to post process, turn on clip, and bring it a bit lower to the ground. And there, now what we've done is we get to keep the slightly smooth and soily structure of the main mountain, but combine the surroundings with the rugged terrain. So that's a great option if you want to go down that route. Now, I'm only showing it to you because that's one way of doing it. For our purposes, I'm going to keep the mountain rugged, because if it's more rugged, we can have like great shelves on which snow can collect. So this was just like an exercise for understanding how masking works. So I'm gonna, and you can apply that to any effect or node. So I'm gonna select the height portion, remove all of that, go back to worst lands and unclip. So I'm just gonna turn this off so it goes back to how it was. And I will right click and refresh the combine node. Oh, there we go. It was already combined. Oh no, wait, it's blending, which I forgot to change back to screen. That's why it looked strange. And there we have our more rugged terrain back. Now, in some ways, I do kind of miss the soil flow a bit. And if you want to bring some of it back, there's a great way to do it. So I'm going to create another erosion node. And this time, instead of having it apply everywhere uniformly, which takes away a lot of the rugged rock structures that we like, I'm going to now go and turn on selective processing. So we have a bunch of options. I'm going to select precipitation amount. And now what this does is that the rainfall, which causes all this erosion, is limited to a very specific portion. So just like we created the height mask before, this is now creating an internal height mask for us automatically. So right now I've selected altitude, and so it's set to a bias of 70%, which means that everything above 70%, so it should be maybe somewhere here, gets rainfall. And so if I now click apply, oops, I think 70% might be a bit too much. So I'm going to go to, I'm just going to type in 95% so we can see the effect more clearly. And so what's happening now is the rainfall, I'm just going to try to find a nice lighting angle. Okay, so the rainfall now happens up top and it brings the sediment down here, but there isn't that much rainfall happening here. And so the lower portions, like these delicate structures that you see here, they don't get affected that much. Now I'm going to take that one step further, and this time we're going to increase random sedimentation. So what this does is, instead of having this nice soil that's consistent, it creates random sized sediment deposits. So if I click apply now, you can see that the softer soil is now being replaced with a lot of larger sedimentary clumps, which can be either soil or boulders or whatever that's rolling down from up here. And it kind of gives us some of that not so smooth erosion that goes well with our rugged intention for this terrain. Now, finally, we're going to do a little bit of cheating, because since this is a simulation, it's doing all these erosive things very realistically. I still miss some of this, like the cutouts and collapses and so on. So what I'm going to do is I'm going to go back to this erosion node, the second erosion node. I'm going to go turn on the min mode for the post-process stack. And so what happens here is that with the incoming terrain, which is this this combined node here, and erosion, it compares the two, and for every pixel on this displacement map, it will choose whichever is the lower height. And so it gives us some of these collapses back and creates a bit of breakup in the original structure for the smooth erosion flows. So with that, we kind of get a really cool looking rugged terrain. I'm going to open up the lighting settings and let's just see how the terrain looks with a bit of different lighting. So that's cool. Here we can see the structure more properly. Oh, another thing we can do is we can just break this up a bit more. And what we can do is use one of the look dev nodes. Now the look dev nodes are meant to give you a specific look without having to figure out like how to do the structure for nodes and so many things like that. And one of them is called Canonizer. So I'm going to drag and drop this on erosion. It'll auto connect, and there. You can see it's starting to create random canyons out of this. Now, I think that's a bit too deep, so I'm going to select a lower maximum depth, but increase the number of octaves, which in fractal language is just the number of different passes it will do to create these terrains. So now you can see it's creating these cutouts. They're very gentle, but they're everywhere. And so they add to the general breakup of the terrain, but also create nice little nooks and crannies where we can get snow to accumulate. And that's something we're going to do once our main terrain shape is finished. Now, to help with Canyonizer, another way to add a bit of breakage is the Anastomosis Node. Now, it sounds very technical, but it basically just creates grooves like the ones that we had. If I go back, you can see in this original one, these flow structures. That's what anastomosis does. And so I'm going to change its downcutting mode from pits to rivers. And I'm going to hit apply. It takes a moment to finish. And it's now starting to carve out these rivers. So I think we can give it a higher impact area, and more influence because we just want it to go full force. And there, now you can see what it's doing. It's using flow simulation to give us these structured cutouts within the entire terrain. It makes our terrain look that much more rugged while following certain laws of nature, which makes it that much more believable. And with that, I think our terrain is generally complete as far as the main mountain structure goes. So you can see the nodes aren't that many. So if you ever feel like, oh my God, I don't like nodes, I don't know what to do with them, you can see that it's not really that hard. What we do is we basically take it one step at a time, think of it in smaller pieces, and then before you know it, you'll be able to tie along a lot of different nodes and then get a very complex shape out of it. So with this, our basic shape, like I said, is ready, and the next step will be Snowfall. So I will go down and look for the Snowfall node, which is right here. I'm going to drag and drop it on top of Anastomosis. And then it immediately starts creating a snowfall simulation. So this is pretty cool, but I think it hides some of our cooler rock structures. So what we do is we increase the melt a little bit, or maybe a bit more. That's too much. So I'm just gonna feel my way to something like this. That's cool. I want to fine tune this, and you can right click a slider and you can have all these micro increment controls. So I'm just gonna fiddle with this a bit. There we go. That looks cool. Now, the reason why we went through this whole process, like even though we kind of had something good looking right here, we went through erosion again, and then canyonizing, and then anastomosis, and all of that is to give us these really cool shapes. Now, if I were to duplicate this and then attach this straight to, say, the original combined node, you can see it looks okay, but it just has these few little bits on the slope. It doesn't really have that much of a broader structure. And the mountain, again, looks nice, and for a distant asset, this would be fine. But if you're going for a hero element, something you just want to stand out and have like a lot of character to it, then taking these few extra steps can help. So now if I switch back to this, you can see it has more structured flows on the sides. The snow accumulation looks a bit better. And the general cragginess of the whole thing, especially if you look at it from the side, like that makes it feel more like a real mountain. Now I'm going to delete this extra node, and like I said, the snow shouldn't be everywhere. It shouldn't be covering everything. We kind of want the snow line to be up here, so we can do a bit of nice forest texturing on the sides maybe. So I'm going to increase the snow line for the node. Actually, this is high up, so there we go. 27% brings it up here. And because again, this is a simulation, the snow that melts and creeps down, it fills the cracks and crevices very realistically. And so that gives us a lot of crispy visual detail whether you use this for like a skybox or an actual asset in the distance in your 3D scene. That kind of detail really helps sell it. Now, another thing that really helps sell this would be a texture, like a full bitmap that you can use to create the material for this, because you can paint this, but that's kind of nasty. That's a lot of work to paint this realistically. Also, because this is procedural, like I could go down here and say, instead of this default shape, I'm just going to change the seed. And so, oh, that looks cool. So maybe I want this. And so now if I go back to Snowfall, you can see all these unbuilt nodes are being rebuilt again based on the change that we created way up the chain. And there we have a whole new mountain. So this way you could actually just randomize and create a bunch of different assets very quickly. And so going through and painting each and every one of them can be a painstaking task, something you probably should avoid if you can, unless there's a very particular reason why you should paint this. So I'll go back because I like the mountain that we had before. So I'm just going to right click and reset this to the original and then let this rebuild. And then we'll create a fully procedural texture for this. And that'll include the general rock and soil. We'll add a bit of forest to the sides and take in the snow coloration. So now, first thing we need to do is to create a texture map or a texture mask on top of which the actual colors will be created. And so for that, you can actually do slope or flow masking like you might with traditional CG terrains, but we can actually cut through all of that, a minor node building through which you would create an amalgamation, and then it's a lot of work. So instead, what we're going to do is we're just simply going to use the texture data map. So data maps are cool. They generate all sorts of information from an existing terrain, and they don't need to be something that you like need to make part of your terrain from the start. So like erosion, for example, if I go here and if I turn on the 2D preview, it'll let us preview all these extra ports, like all these extra outputs. I didn't go into them in detail because they're not really relevant to what we're doing right now, but let's say you do want to see the flow structure of it. I'll right click and select flow instead of the main output, and you can see this is the flow data generated by erosion, or the wear data. This is, I'll actually click enhance visibility so we can see it better. So this is all the wear and tear that the erosion process puts the terrain through, and those masks can be useful for creating texture maps. But again, because we are modifying it further, these kind of become obsolete and they don't really represent the final product that we have going on here. So instead of worrying about any of that, all we have to do is towards the end, we just drop in a texture node. Now, because we're dealing with snowfall, which kind of adds to the terrain shape, like not much, but it still adds bulk to the sides here, I'm going to connect this to before snowfall because we want the texture to represent the ground itself, and snow will just be a layer we add on top of it. So once we connect the texture node, you can see it's creating this intricate pattern for us. Again, if I turn on the 2D view, you can, and then also turn off the 3D shading, you can see this is the structure it's created because it takes into account slopes and soil flows and then the normal fluvial erosion flows. It adds a bit of chaos and all this stuff, and most of the time, even in some of the most advanced projects that I've used, I rarely have to go in and mess with this much. So in our case, this is going to be, pretty good. So we don't need to worry about it too much. We don't need to change any settings here. What we can do is we can create additional data maps. So now that we are previewing 2D things here, and our shape is Snowfall, or rather the final shape is Snowfall, I'm going to right click this and mark that as our underlay. And so now when I switch to this, we're properly seeing it on that final shape. So this is cool. I'm going to add one more data map, which is the rock map. So when I drop this on Anastomosis, you can see it's now creating a rocky map that we can use for the more carved out features. And so we can now combine texture and rock map. So again, I drag out, and instead of creating the combine node like we did before, I can just drag an out port to and connect it to another out port. It'll then combine it for me, creating this the combine node with both of the textures. Right now it's being viewed as a 3D map, not a texture map. So I can right click and select show as mask. And so now with the Snowfall node being our pinned underlay, when I go back here, I get to visualize it properly on this. So now we have to decide how we want to blend the two together. I think a great way would be, because this is quite bright and has a lot of brighter grays than darker grays, we can subtract the rock map out. And so I'm going to go, and instead of blend, I'll select subtract. And that's a really high value, so I'll go somewhere here in the neighborhood of 15. I think because we want to subtract it, and the rock map actually highlights the rock portion and not the crevices, we want it to be the other way around. So I will uncheck invert. Now invert is a handy option that we have in rock map, but if you didn't have it, you can always create an invert node, or you can go down here and select invert in the post-process stack. So now these lines that we see here, those are the ones that are going to be cut out from the texture, or subtracted rather. And I think this is a bit aggressive, so I'm going to reduce the density by maybe half, a little more than half. And then when we go to the combine node, and I'll refresh this, you can see that okay, it's not affecting it that strongly anymore. So now we can go a bit higher on the ratio, and you can see it's starting to break up our main texture. Now I'm not going to take this all the way through, because then it becomes too much like our main rock map, and it can not it takes away some of the subtleties, or well, most of the subtleties actually. So I will right click and go half and half again. So about 25% seems good. We can come back and mess with it later, because right now all we need to do is set up the basic mask through which we can flow color. And so this process known as colorization. So normally with traditional terrains, what you would do is you would create a colorizer node. So in our case, it's the clutter. And so it basically maps the color gradient that we create here to the entire mask. So white becomes whatever's up top, black becomes whatever down here. So if I were to change this and start giving this dark brown tones, like it would match a real terrain, you can see now that's starting to happen. I can add another stop and, let's see, maybe something grayish. And then now I can move this around and see it flow across the map. And that's how you would normally create a custom color gradient. And that's a great way to do it. It gives you options, but again, it takes a lot of time. So instead, we're going to use a satellite map. So if I scroll down further, you'll see the purple color node here called Sap Maps. Sap Maps is basically a collection of gradients that Gaia has that were created from actual satellite images and other natural references. And it comes in these different categories, like rocky, for example, is perfect for what we need to do here.
Hey,
and so you can see this is the color map that it's creating for us. Now, or rather that's the color map that it's using to generate the texture for us. Let's try this one.
Yeah.
Oh, that's a bit too bright and slightly pink maroonish. So I'm gonna scroll until I find something that looks a bit more realistic.
Does it work?
For our case, let's see, maybe this one. Oh, that has a lot of nice crinkly detail to it.
Yeah,
we can bias it towards one side or the other. That's a bit too green. I think I like it like this. I think it's still a bit too bright. So let's see, let's scroll down further, see if we can find something nicer. Nope.
Okay,
nope.
Great.
Nope. Great, but not for this. I just reset the bias so we get to see the real look of it and not a biased look of it.
Well, I would prefer
bias is something you should do only after you find out what the terrain mask or the color map is all about.
Okay.
So let's see. I like these shades.
Okay, I can just start by myself if there are any questions from.
But I think we can bias it
Discord.
Make them dark. They're still a bit too colorful for me. So what we'll do is we'll just open up post-processing and do apply HSL.
Thomas,
and I'm just going to reduce the saturation on this. I think at the same time we can do brightness contrast and reduce the brightness on this as well.
Okay, freelance.
A bit less saturation.
Illustrator.
That's a nice mask. That's a nice base mask for having rock structure on top. I think to keep it very realistic, I think it should have less saturation. Have it almost be gray, but not completely gray. So that's a cool mask or cool color texture that we have going on. But again, we don't have to settle for just one. I'll create another one. And let's go quickly look for another map. I know we're really far down.
Okay, thanks.
There's some cool gray ones here. Maybe a bit too gray. This one, maybe if I can bias it a bit. It kind of has some nice structures in it. A bit green. So I'm gonna go and change to something like this, which is similar but without the green. And now I can combine these two, but then at the same time we can mask them separately. So I'm going to go create a Perlin node, just a simple Perlin noise, and I'm going to auto level it so it gives us the full height range. We'll reduce the scale so it's like a lot of noise, and then we'll use that as a mask for combining these two different satellite maps. So when we go to the combiner, we neither get this or this, but an amalgamation of the two. So I'm going to change the blending to 100% so it follows the mask almost exactly. Again, in our case, is a Perlin noise, and there we kind of get the best of both worlds. Now we can go back and we can change how the rock map is subtracted. So I'm going to increase the ratio. Let's get a lot of craggy detail going in there. And then if we go to the combine, you can see that's now being reflected. And now that we know what our sat maps are doing exactly, we have a better idea of what will happen if we go back and change the rock map. And so there we have our rock and soil layer. Now, I think the next step would be to add a little bit of green. Now, you saw that in this one, we did get a little bit of green, but I removed it. Because when you have green in your main rock map, it's a very difficult thing to control. You can't get the placement right. And so for that, we actually take the combined final color map or the rock map or the rock color map, and then I'll drag a line out and then I'll select vegetation. So the vegetation node takes two inputs. One is the height, which again in our case should be anastomosis, not snowfall, and then the color map on which we want to add vegetation. So now when we go here, it's added a few specks because this is a really steep sloped mountain. So we'll need to change the influence here, which is the slope bottom mainly, to halfway. Now apply changes. And then you can see it's now adding vegetation on top of our color map, saving us the trouble of having to somehow squeeze it into the main gradient. And if I take jitter and hit apply, it'll start making these dots a bit thicker and more prominent. I think I'll increase the slope bottom a bit more and then introduce a bit of chaos, because we don't want just very precise shapes. We want kind of a flow over going everywhere. So there you go. Now our mountain is starting to look really nice and realistic. And so now all we're missing is the final piece, which is snow. Now, like we saw the flow map and other data coming out from the erosion node, the snowfall node gives us the snow mask. And you can choose what kind of snow mask here. So right now it has a soft mask, but because we're going to do color blending, I'm going to choose a hard mask. And then if we go to the 2D view, you can see the hard mask like so. So that is exactly what it is. It just gives us the full coverage of the snow. Now going back to 3D mode and going back to output, we're going to take the vegetation node and then add the snow on top of it. And to do that, we take the main output from the vegetation node and then touch it to the snow of the snowfall node. And it's created a new combine node, which we will change to max mode, which takes the brighter of either pixel. And in our case, snow being white, or rather the mask being black and white, we will automatically get the white to come up everywhere where it needs to and overwrite the color pixel. And so all we need to do is set the ratio to 100%. And so now our snow has come in and we get a nice little spring mountain. Well, not little, it's quite large actually. And it has snow flowing down. It's now starting to melt and we have vegetation growing everywhere. And like if you were to go back and change the snow line, let's say you don't want it to come down all the way here, increase it to say 34. There we go. We just have a little bit of remnant from the winter. Go back to our combine node and there you have it. Now, before we do anything else, or rather before we finish and save our terrain as an actual asset, let's preview it at even higher resolutions. I'll switch this to 2K. And there. The whole graph was reprocessed at 2K, which is 4 times larger than 1K, if you look at it from a pure pixel perspective. And now we can see even more detail in our terrain. So we have all the nice craggy rock. We have vegetation growing everywhere. We get our beautiful snowfall and the deep grooves. And again, like we saw, since this is procedural, there's nothing stopping you from going back, changing something and having the changes propagate all the way through, and everything including the color maps will be rebuilt for you. So now the last step is to take this to wherever you're going to use it, whether it's a CG application like Max or Maya or Cinema 4D, or you're going to take it to a game engine. Now, one of the great ways to do it is take it as a displacement map. So if I wanted to do that, I just need to identify my 2 main resources. So the first is the height map, and that generally is the last node that does the height modification. So in our case, it was snow, because snow, while adding just all the white that we see, it's actually adding structure. There's a lot of detailed snow simulation going on, and so when we export this at say 8K, that will be crucial. So what we do is we go to Snowfall, right click and mark it for export, and that's our main height map or displacement map that we can use on a flat plane to create our terrain. And the other one would be the diffuse map. So you go here, which is combine, it's the last one, it has all the beautiful color. And so right click that and mark that for export. Now, maybe you would want a mesh instead of a displacement map. So if that's the case, then take your last node's output, which again, it's snowfall in our case, drag a line out and add a mesher. Now the mesher node can save an OBJ, FBX, or even a point cloud. And so I'm going to give it a vertex count of 1024, which is basically 1024 by 1024. You can see how many vertices and faces it can give you. If you want even more, if you want it to be exactly the same level of detail as your height map, which in our case is 2K, I can right click and type in 2048 and have it use quads, have a bit cleaner geometry. And then now if we go to the build tab, you can see that our two nodes that were marked for export are ready. Mesher, because it's an output node, it's all automatically always ready. I'll change the combine to use something lightweight like a 16-bit PNG. That's because it's just a color map. And then for our Snowfall, which is a displacement map, we wanted to have like full 32-bit fidelity. And so for that, I'm going to select EXR. And so now all that's left to do is just hit build. It'll create these assets and then you can take them anywhere you want. So thank you for joining me on this little tutorial on how you can create procedural terrains. Everything you see here can be done using Gaia's free edition. So I hope you try it out and create some really cool terrains that you can use in all sorts of different ways, whether it's for architectural purposes in the background, or a big VFX shot, or skyboxes for your games. And so this procedural workflow will hopefully save you a lot of time and you'll be able to get way more quality out of it. So thank you again and hope you have a good day.